Now move on to our final formal presentation of the day. I'm delighted to welcome Chris Johnston here from IrBEA Northern Ireland. Chris is a project leader in environment and renewables. We work closely with Chris in a lot of work, and I'd like to thank Chris for his input in terms of the EIP project over the years as well. And today Chris is going to present to us on an update from Northern Ireland, where there's great work taking place around enhancing nutrient management with slurry and digestate separation. So over to you, Chris, for the slides.
That's great, Sean. Thanks again.
Yeah.
Thanks for the introduction there. So what I'm going to talk about here is a slightly different sort of angle on it. We're looking at anaerobic digestion as a solution to our nutrient problems. What I'm going to talk about now actually is a kind of an innovation and an impetus been set up by the Department of Agriculture and Environment and Rural Affairs. And we don't actually have the responsibility for energy. That would be more coming under the Department of Economy and Energy. But this is where the anaerobic digestion fleet we have, and there's been some mention of it today already. We do have 80 or so plants operating, and we're looking very much at using the AD sector to help with the production of bioenergy, absolutely, but to also manage our nutrient base. And I just want to put that picture quite clearly at the start. You all live here, you know we have a lot of nutrient problems up in the north. I mean, we do have them sort of in the EU as well. We have them in the UK, but we've got a lot of problems in the north that have really hit the news, the media, the headlines. And agriculture has a big responsibility for this. And this chart, I think, makes it sort of quite clear. That greeny, yellowy colour, whatever it is basically a measurement of the total phosphorus input that we have onto our farms every year. And we can see that it's been growing and growing and growing. And the red line is a reflective indication of the water quality based on soluble reactive phosphorus in our waters. So what we can see there, I think, is quite clear. There's definitely an increase of PE imports onto the farm. When I'm talking about phosphorus imports, it's mainly animal feed to drive largely the dairy herd, but also the poultry, the pigs, everything else. There's a big import of nutrient. Not a lot of that PE import, well, I say not a lot, it's probably about 10-15% is actually phosphorus fertilizers, but the total PE imports are really significant. And the red line is reflective of what it's doing to our water quality. And that's basically 50% up since about 2012. So that's quite a big jump. And it's no wonder we've sort of heard quite a lot recently about our nutrient problems. Translating that onto this particular graph here, this is just saying the same thing in a slightly different way. This is when we bring it down to a farm phosphorus surplus. So on average, all our farms have a surplus these days of about 10.8 or something. It's gone up slightly for the following year. The line at the bottom, that green line, is indicating where we need to get to. So we need to reduce the amount of phosphorus we're bringing onto a farm in order to achieve what we need to do. And those of you with an interest in water quality and how that reflects from diffuse runoff and agricultural inputs. There was a paper published at the weekend by Ulster University and IrBEA that actually shows that if we can bring our farm balances down to that green line, we can actually regain good good chemical status under the Water Framework Directive. So this is really where we're trying to get to, and this is the main preemptive or pretense of what I'm going to discuss now. That, I'm not expecting you to read that, but just so you know this bit of work was done. This is just a map of all the phosphorus imports in and out of the country, in the north. All the ones on the left, just looking at the big lines, because it indicates the quantities. So don't read any of it, but you see on the left, those 5 lines are all imports. The big black line, that's feed, and the one above it is fertilizer. The others are imports of foods and fish landing and things like that. But those are all the imports. And then the ones on the right, they're all the exports. There's not as much. What we need to really look at is the imports are way more than the exports, and those big lines up at the top is basically slurry being recycled to the agricultural land base and ad infinitum, on and on and on. So we're circulating all this nutrient. So the only way we can get around this is by exporting an amount of this phosphorus, or import less. But then, what does that mean for our agricultural herd? For our national herd. So that's really where we're coming from. Hopefully that's kind of clear, because that's the reason why we're doing this. Then we did a piece of work that was sponsored by the Centre for Advanced Sustainable Energy based out of Queen's University, which was going to say, well, if we did start to kind of look at Northern Ireland as a whole, what could we do in terms of decarbonising our energy, decarbonising our gas grid? Is it actually worth doing, essentially, is the question. If we were to start to use our own innate, natural, located resources, such as slurry and energy crop, can we actually achieve something? And I've summarised another publication basically into one slide here, and that just kind of shows, I think on the left there, we're looking at housed manure, and on the right, we're looking at underutilised silage. So this was done by a PhD student who looked at really quite fine detail of what we could manage to gather up across the country. The bottom line there is we could indeed create about 7.5 gigawatt hours. We brought a bit of reality into this. It came down to about 6.5, I think 6.8, and a third of that biomethane could be produced by the slurries, and the other 2/3 could be produced by excess silage, is what we call it. So it is possible to get somewhere along those lines. Now that it's worth mentioning as well, that's 6.5 or 6.8 terawatt hours that the modelling, and I do rephrase, was only modelling, that it came up with, was picked up then by the UK Committee on Climate Change, and actually that came out in the last recommendations to Northern Ireland, that we should be aiming for about 3.5 terawatt hours by 2050. Okay, so that's kind of, they picked up on this piece of work and said, guys, you do need to do this. There is a real opportunity for you to use your agricultural wastes, residues, and purpose-grown crops in order to achieve this. So, in a one slide, this is what we've suddenly started doing over the last, and if you picked up any of the news, over the last sort of month or 2 months. What we're looking at here is a scheme and a strategy by which, looking at the very top bubble there, the green one, what we want to do is we want to gather up as much slurry on the farms as we possibly can do. We're not talking about transporting liquid slurries at 5%, 6%, 4% solids. We want to process the slurry on farm. It's already been mentioned a few times, Joseph mentioned as well there, we will then also, what that will do is it'll partition a significant portion of that phosphorus into that solid material. Now we can transport that solid material off towards central biorefinery systems. In this case, we're referring to our innate AD plants that we have, the ones that are currently running, and we see in the future we will need a lot more of them, as you're looking in the south as well. But for the time being, we have recipient facilities to take that feedstock. We know the biomethane potential, it does vary, but that particular dewatered slurry material has a biomethane potential. So bringing that all the way through, slurry export, down to an AD plant, and then finally the production of the biomethane, which does need to be cleaned up and got to go into our gas grid. That's where we're looking at forward now. We're not really talking about an awful lot more electricity from AD. And then finally the digestate material, which is the whole reason why we're doing this. That digestate material that is coming out the back of those AD plants, that's to be exported. And that's the bottom line. I'm not going to go through all those messages because I think we've gone through them quite a lot before, but that's the strategy. So what's happened in the last number of months? We ran a phase 1, we spent 600k, which was essentially looking at things like nutrient separation, phosphorus separation, nitrogen separation, the efficiencies, all that kind of stuff, farmer engagement, a lot of that as well. We spent 600k in that phase 1. And then recently now we managed to get approval for 12 million. 2/3 of that 12 million has already been handed out, contracts signed, to 2 organisations, which are listed below there in phase 2. There will need to be a third one announced at some point as well, but so far 2 of them have been announced, and they are actually up and running. Just to add a little bit more credence, I feel, as to why we're doing this and what we're doing, apart from all the stuff I showed before about our nutrient and our nutrient problem, and this management or this strategy is very much about addressing our nutrient problem, but it's producing a feedstock for AD. You've heard about our Loch Ness problems. I've just mentioned it at the bottom. There's actually 2 of our Department of Agriculture ministers' action points which are addressed by this particular strategy that we've implemented, which are those 2 you can see below. So we are actually progressing some of the steps that we've said from an executive point of view that need to be achieved if we're going to get anywhere to where we need to get to. Just a few pictures I think is always nice, but we've seen a few pictures of AD plants and things before, so I don't have a picture of an AD plant. But top left picture is just a demonstration of what we did in phase 1. One of the organisations was using a mobile screw press, separating digestate, and then pumping the discharge from that screw press into a tank. The solids material is then brought away to an AD plant, and that's entered into the nutrient removal chain, if you like. The picture in the bottom left is a mobile bed of 6 screw presses. There's already one of these up and running now in the north. There'll be another couple from that organisation, and from the other awarded organisation, there'll probably be certainly one by this time next year, maybe two by this time next year, and a third one. So we could have 4, 5, maybe 6 of these mobile screw presses running around farms, separating slurry, removing that nutrient to another site, taking that nutrient pressure off those farms, if you like, reducing that P surplus I mentioned before in one of those graphs. So this is a strategy we're doing. And then there's been a bit about nitrogen removal. That's just a picture of one of the nitrogen removal technologies, ammonia removal technologies that was also demonstrated during these particular projects we've been running. So I think just final slide here. A lot of this is about agricultural engagement, it's about farmer engagement, because no one's really considered this to any great extent before. And a lot of our farmers, it's very, very new to them. But the ones that we've worked with in the phase 1 gave us these kind of responses. They sort of were saying things like, you know, you taking away the solids actually has given me more room in my tank for more slurry, which helps me a bit. You've also, I'm also finding that because of the reduced dry matter in my slurry, because of separation, it actually runs through my low emission spreading equipment an awful lot better. They may also say things like, do you know something? I know I've got quite a lot of phosphorus on my farm, so actually I feel as though this is quite a good environmental thing to do, although I haven't really measured it, but I think it's right. So we've had really quite good positive results back. We've also run a number of days, you know, survey days, which my colleague Ashley has developed here. And that QR code actually is live if there's any farmers who would like to express their feelings on this kind of a theory, this kind of a strategy. You know, we are ongoing with an awful lot of farmer engagement over the next number of years. And actually, there's a cross-border element to that as well that I can discuss. But we do need a significant amount of farmer engagement, and we're planning to do that because it is a change, it is new, it is something that we need to certainly, I think, sort of train and educate and to see the benefits. But hopefully this little presentation has given you a good understanding of why it is indeed we're doing what it is we're doing. We've got environmental problems, and AD is what we see is a route to solving that, with the byproduct being biomethane. Okay.
Thanks very much, Chris. Very interesting presentation on the work that's happening in Northern Ireland.